Hi, my name is Haziq Adlan bin Mahatta, and today I will be talking about introduction for application of first order. ODE, there is growth and decay. It is an exponential function. In other words, exponential growth that refer to a situation where a quantity increases at a rate proportional to its current value. Exponential decay occurs when a quantity decreases at a rate proportional to its current value.
Hi, my name is Nick Zikri. Today I will present about problem statement 1. Hydrocodone beta trait is used as cough suppressant. After the drug is fully absorbed, the quantity of drug in the body decreases at a rate proportional to the amount left in the body. After 3.8 hours, the amount of hydrocodone beta trait left in the body is half of the original dose taken, which is usually about 10 mg. What is amount left after 12 hours?
Hi, my name is Muhammad Hakimin and I will present the fila table for this question. First, I will present about the facts. As the drug is absorbed, its amount the body decreases proportionately to the what it left. After 3.8 hours, the remaining quantity of hydrocodone treated in the body is reduced to the half of the initial dose, which is typically around 10 milligram. The question asks for the quantity that remain after period of 12 hours. And for idea of this question is the level of drug in the body diminish in direct proportion to the amount that remain as it absorbed. Approximately 3.8 hours after ingestion, the quantity of hydrochloride bitrate still present in the body is reduced to the half of the initial dose, typically around 10 milligram. The question pertains to determine the quantity that remain in the body after a duration of 12 hours. For learning an issue, first we need to understanding proportional decrease in a drug level. We need to calculating remaining quantity after a certain time. We need to finding the remaining quantity after 12 hours. We need to interpreting and applying information, like we need to applying mathematical reason, and we need to understand real life implication, like we need to improve reading comprehension and communicating finding it effectively. And lastly, for the resource needed, we need to instructional material on a proportional decrease and remaining quantity calculating. We need to practice problem and worksheet. We need mathematical resource and tools. We need real life case studies and example on drug absorption and dosage and adjustment. We also need to reading material with drug-related passage and questions and collaborative activity for communication and teamwork.
Assalamualaikum and hi. My name is Hanif Naufal bin Muhammad Hassan. Now I will explain the solution statement 1. So we have to use the exponential decay. Step 1. We must know the general form of the equation for exponential decay is nt equal to n0 times exponent square root negative kt, where nt is amount of drug remaining at time. N0 is initial amount of drug, K is a decay constant, and T is time. Now I will continue to the step 2. After 3.8 hours, the amount of hydrocodone bitrate left in the body is half of the original dose. The original dose is 10 mg. Next, 5 mg equal to 10 mg times exponent square root negative k times 38. Now to find the value of k, we can solve this equation for k. Next, exponent square root negative k times 3.8 equal to 5 mg over 10 mg. 5 mg over 10 mg, we can get 0.5. Next, negative k times 3.8 hour equal to long 0.5. Now we can get a K equal to negative long 0.5 over 3.8. Now we go to the step 3. Now that we have the value of K, we can use the equation to find the amount of drug remaining after 12 hours. And 12 equal to 10 mg times exponent square root negative K times 12. Step 4. For the calculation, we can get K equal to negative long 0.5 over 3.8. We get 0.1823. Now, N12 equal to 10 mg times exponent square root negative 0.1823 times 12, and we get exponent square root negative 2.1806. And now N12 equal to 10 mg times 0.1121. Now the final answer for the N12 is 1.121 mg. Therefore, approximately 1.121 mg of hydrocodone bitrate will be left in the body after 12 hours.
For the introduction for the application of first order ODEs, Newton's law of cooling. It is a mathematical model that describes the rate at which the temperature of an object changes with respect to time when it is exposed to a surrounding medium of a different temperature. It can be formulated as a first order ordinary differential equation, also known as ODE. The law states that the rate of change of the temperature of an object is proportional to the difference between its temperature and the temperature of the surrounding medium.
Problem statement 2. You remove a cake from an oven at 10:30 am. At that time, its temperature is measured at 300 Fahrenheit and was put on the table where the temperature of the dining room is 70 Fahrenheit. At 10:33, its temperature is 200 Fahrenheit. You want to eat the cake when the temperature is 85 Fahrenheit. Then, how long will you have to wait for the cake to cool off to 85 Fahrenheit? Suddenly, you change your mind and want to eat the cake with your friend, but your friend will be home about 1 hour later. So, what is the temperature of the cake when your friend reach home?
Fill a table for this question. I will say about the fact first. The cake was removed from oven at 10:30 am and the temperature of an object was measured as 300 Fahrenheit, and then it was placed on a dining room table with a temperature of 70 Fahrenheit. The cake temperature is 200 Fahrenheit at 10:33 and the plan is to eat when it cool down to 85 Fahrenheit. How much time will take for the cake to cool down to 85 Fahrenheit? And what will be cake temperature when the friend arrive home in about an hour? The idea of this question is cake removed from oven at 10:30 am. Object temperature measured at 300 Fahrenheit and placed on the table with temperature of 70 Fahrenheit. Cake temperature recorded as a 200 Fahrenheit at 10:33 am. We plan to eat when it cooled down to 85 Fahrenheit. The time required for the cake to cool down to 85 Fahrenheit and the cake temperature when the friend arrived home in approximately 1 hour. For learning an issue, first we need to understanding temperature measurement and unit, grasping the concept of the heat transfer, interpreting temperature change over time, applying mathematical calculation for cooling time, graphical representation for temperature change, and handling time conversion. And for the resource needed, we need to provide clear explanation of different temperature scales provide practice problem with very fine level of difficulty to reinforce the calculation skill. Show and create graph to visually represent temperature change over time, foster discussion and collaborative project to deepen understanding and explore practical application of temperature related concepts.
Hi, my name is Muhammad Shaidarwish bin Khairul Anwar. I will present for the solution statement 2. For this statement, we have to use the Newton law of cooling. So, let's start with the first step. We need to determine all the information given from the statement, where T0, the initial temperature is 300 Fahrenheit, TE is the surrounding temperature is 17 Fahrenheit, and the temperature of the cake after 3 minutes is 200 Fahrenheit. So, for statement 2, we have to question which is how long do we have to wait when the temperature is 85 Fahrenheit, and what is the temperature of the cake after 1 hour. For this question, we have to use the formula Newton law of cooling, which is TT equal to TE plus T0 minus TE times e power of negative k times T. For the second step, we need to find the value of k. We simply enter the information given from the statement into the formula. So, we get the value of k is negative ln 30 over 23 divided by 3. For the third step, we need to enter the value of k into the formula and the time required for the cake to reach 85 Fahrenheit. So we get the time when the cake reached 85 Fahrenheit, which is 40.35. On the last step for this statement, we just enter the time that we want in the formula. For this question, we have to determine what temperature after 1 hour, which is 16 minutes. So, we just enter into the formula and we get that the answer is 70 Fahrenheit. Okay, that's all from me. Thank you. For the conclusion, in problem 1, we have used the exponential decay equation to model the amount of hydrocodone butyrate remaining in the body over time. After 3.8 hours, the amount remaining was half of the original dose, 10 mg, allowing us to solve for the decay constant, k equal to 0.1823. We then use this value to calculate that approximately 1.121 mg of hydrocodone butyrate will be left after 12 hours. In problem 2, we apply Newton's law of cooling to determine the temperature of a cake at different time points. The equation used was TT equal to TE plus T0 minus TE times E power of negative k times T, whereas T is the temperature at time T. TE is the ambient temperature, T0 is the initial temperature, and K is the cooling constant. Using the given temperature data, we found that K equal to ln 30 over 23 divided by 3. With this value, we'll calculate that the cake will be at approximately 17 Fahrenheit after 16 minutes and will take around 40.35 minutes to cool down to 85 Fahrenheit. In summary, the analysis shows that after 12 hours, approximately 1.121 mg of hydrocodone butyrate will remain in the body. Additionally, the cake will cool down to about 17 Fahrenheit after 16 minutes, and it will take roughly 40.35 minutes to reach a temperature of 85 Fahrenheit. That's all from me. Thank you.